So for homework, for some of you have questions about the questions. So let's take a look. Question 2 and 3, we have some problem because I think that there was a typo on the top, but just keep going as you see in the slides here. So I mean, like this one is not 0/0 if you plug in 1/3. So you can claim that this is actually the limit does not exist. So the function is not continuous anyway, this one as well. So I think it's just because I copied the wrong number from the textbook or something like that. That's why it's a little bit confused for some of you who want to use conjugate, or some of you want to use the factoring, but you cannot do it because the top part is not 0 on both one. So anyway, just do the question as you see on the slide here. That I mean, if it is some number over 0, it means that the limit is infinity, and that means the limit does not exist. Okay. Another two questions that some of you have problem is this one and this one. So I would suggest that for question 7, you start from differentiate w with respect to v first, and then by the chain rule you should get w by x, and then by x or v, and then plus w by y, and then y by v, and then you just keep breaking down the terms by you because you have the formula, you can compute curl x by curl v and curl y by curl v. You can do it because you have the formula here. And then after that, once you kill this thing to 3, kill this thing to u, so you can apply one more time the derivative with respect to u, and then it's gonna be a little bit complicated now because you have to apply the chain rule on here, the product rule, and the chain rule on here, and then you keep simplifying it, so it should be at the end this term. Makes sense? But it's gonna take a little bit calculation because you can see the answer that it have 5 terms here, so you just need to simplify until you get this one. Should work. It's gonna require you to apply the chain rule and the product rule on that question. And then question 8, so the hint is that you need to find the critical point first. So you differentiate this one with respect to x, you should get 3x squared and then minus 6x and then minus 9, right? Is it the derivative with respect to x? Does it make sense? And then when you take derivative with respect to x here, you set it equal to 0. Can you solve for x? So this is actually 3 times x squared minus 2x minus 3. This is, you actually can solve for x, right? And then the same thing if you differentiate with respect to y. So you're gonna get 3y squared minus 12y. This is actually 3y times y minus 4. So you can, and if you set it equal to 0, you can solve for y. So you're gonna have solution for x and y, and then you plug in to check if it is max or min or saddle point, or if it is inconclusive, you say that it is inconclusive. Does it make sense?
The matter is that when I try to determine the point, which is whether it's local min max or saddle, I always end up in this that it shows it is inconclusive. I don't know why.
Well, if it is inconclusive, you say it is inconclusive. That's it.
I mean, yes,
yeah. But I copy it from the book. It shouldn't be like all conclusive. There must be some point that it is a saddle point or max or min. Okay. All right. So that is the hint for the homework here, which is due next Monday, right? This is 19, so 5 days from now it's April 24th. Okay. So make sure you submit it on time, April 24th. And then we're gonna have the integration part for the content today. So we're gonna keep going on the integration. I think we need 2 more weeks, like this Wednesday and then the following Monday and Wednesday, and then we're done for the content. And then now we can do the mock exam together on the next class if you want to, on the May 3rd. And then we're gonna have the exam on May 8th. Is that May 3rd? May 1st? Yeah, the first, the Monday before the exam, we can look at the mock exam together. Make sense? So the content that we have left is only the integration part here. This is the one that we need to know how to integrate into dimensions. We're gonna learn it today, next Monday, and next Wednesday. 3 days to learn about integration. Good? All right. Anything else? Any questions? So I think we should start the integration content now. So let me review you from last time. The last time, what we did is we learned how to integrate into dimension when the domain is the rectangle. So when domain is a rectangle, or the rectangular box here, you can integrate with respect to x or to y. You can choose which one you want to do first. You can do the x dy or dy dx, it doesn't matter. We're gonna start by doing example 36. We already did it, right? This is the same thing. Okay, I need to delete this page. So basically today we're gonna start double integral over general regions. So this is the one that you have in general. How do you integrate into dimensions? So what we're gonna do is we're gonna just need to pick the order of integration dx, dy, and dy dx depend on the picture that you have. So some regions are best treated by looking at the x dy. Some regions are best when you do dy dx. So here is the idea. So let's move to page 14. Here is the idea. So let's suppose that you have the domain D here that you want to integrate with respect to. And then one way that you can do is you can draw a box outside the domain here. And then what you're trying to do is you're trying to cut the box, slice it vertically. So it's gonna be something like this. So basically you're trying to get the idea from the rectangular integration to the general domain. So you can pick the order of integration to be dy dx. So when you pick the order of integration by dy dx, it means that, but now you're not looking at the bottom line and the top line here. Now what you did is you're looking at the bottom line here and the top line here. So what you need to switch it, you're gonna switch from, before you start y from one number to one number, right? Before you start from y to one number, before you're gonna say, oh, อาจารย์ครับ y start from here to y to here. But this time you're gonna start from this curve, the bottom curve, to the top curve. So if this is your g1 function, if this is your g2 function, this is actually your top curve and bottom curve. And then you put the bottom curve here, you put the top curve here on the inner integral, and then the outside part gonna be the domain of the integration. This is gonna tell you where you do the cut, where you do the slice here. So if you wanna do dy dx, what you do is you set up integration like this. So the idea is, here's the key point. If we use dy by dx, then we slice by using the vertical line. If you do dy by dx, it means you slice the picture by using the vertical line, because you want to know which curve is on the top, which curve is on the bottom, and the top curve gonna be on this domain of integration. The bottom curve gonna be on this domain of integration. When it's come to example, it's gonna be a little bit easier because you see the function. And then a to b, this is going to be the domain of the x value. So in contrast, if you want to do the x dy here, it means you slice horizontally. So if you use the x dy, it means you slice horizontally. If you feel like it is super hard to memorize that you're gonna slice vertically or horizontally, so the key idea is if you do dy dx, you do vertical line. If you do the x dy, you do horizontal line. But what I want you to memorize that which one you do first, you slide on that axis. Let's say if you want to do dy dx, it means you have to draw the vertical line because you slide with respect to y-axis. And if you do the x dy, you do horizontally because you're going to slide with respect to x-axis. So we're going to take a look at example so to make sure that you understand how to set up the integral into dimensions here. So let's go. Okay, this is a theory. So example 37, I want you to compute double integral over the set S of y minus x dA, where S is the region bounded by the parabola y equal to x squared and the line y equal to 2x. So this question I already gave you a picture. So this is the picture y equal to 2x. This is the line y equal to 2x. And then I also have parabola y equal to x squared. Okay. So there are two ways to set up the integral. So if I ask you to say that, okay, อาจารย์ครับ can you set up integral y minus x dA over the set S? So you have two ways to set it up. So the first way is you can, this is the first method that you can do. It means you can pick to do integrate y minus x dy dx. This is the first one. You can do it. Or you can pick integrate y minus x dx dy. There are two ways to do it. If you choose to do dy dx, what would you do? So you're gonna say, oh, we do dy first. It means you have to slide with respect to y. It means you're gonna do here vertical line because this picture gonna be dy dx. This picture gonna be the x dy. So the difference is if you do dy dx, it means you do it horizontally. If you do the x dy, it means you do vertically. So the best way to memorize which one you do it first, it means you slide with respect to that axis. So if I do dy first, I slide with respect to y here. So how do I know that what is going to be my domain of integration here? So what we're gonna do is from the first picture here, you draw this, you slice the line vertically, right? So you have to think which one is on the bottom curve, which is going to be the green one. The top curve gonna be the yellow one, right? The yellow one gonna be always on the top, and the green one gonna be always bottom, right? Does it make sense? Which mean you have y equal to x squared in the bottom and y equal to 2x on the top. This is how you set up. And then now you're taking a look at the domain here of the x value. X start from where to where? So x gonna start from 0 to 2 because this is your domain of integration, 0 to 2. So x gonna be 0 to 2. Does it make sense for dy dx? If you understand the idea that the integral can be set up like this, so you can repeat it again with the dx dy. So for dx dy, what you do is you slice horizontally. So you have to think which one is on the left, which one is on the right. So here, the one that is on the left is going to be the orange one. The one will be on the right, that is going to be the one that I draw the blue one. The blue one gonna be on the right hand side. The orange one gonna be on the left hand side. So when you do it, so you're gonna start from the x, so x gonna be from where to where. So the left one, which is the orange one, it's gonna be x equal to 1/2 times y. So it need to be 1/2 times y because this is y equal to 2x, and then you simplify it to x equal to 1/2 times y, and then here y, x equal to square root y, because this is x equal to square root y because this is a parabola, and then y gonna be from 0 to 4 because this is the range. This is the all the y value that you're gonna do the slice, right? So this means y from 0 to 4. Make sense? This is how you do the integration. So you have two ways to do it here, or dx dy or dy dx. Depending on the question, you can pick whatever you want. So the first thing that you need to learn when you learn double integral is you need to learn how to set up the domain or the boundary of the integration, and this is how you do it.
But why don't you integrate from 0 to 4 instead of x squared to 2a?
No, because you cannot integrate from 0 to 4 here because the domain of the integration is S. So they want this, just this area, not the rectangle. This is just S. So idea is that we want to compute the integral over S, and S is given to be on this region. So it is not rectangle. So keep in mind that before, when you do it with a rectangle. So when you do it here, r equal to 0 to times 0 1, it means that your domain is x from 0 to 2, x y from 0 to 1. So the domain gonna be rectangle. So here, what you did here, it's gonna be like x from 0 to 1/2, y from 0 to pi over 2, right? So it's gonna be that when you draw the picture, it's gonna be x from 0 to 1, y from 0 to pi over 2. This is the rectangle. But this topic, we are talking about the integrals over general region. So it is now any region that you can have. It doesn't have to be the rectangle. So what you do here is just like you gonna say, oh, we're gonna take a look at the picture first. The picture should be cut in two ways, vertical line or horizontal line. Which one is easier? You can pick that one. For example, I show you the example here, that suppose that I let S to be the region here. S, this is this region. So if you pick to do the y dx, it means you slide this way. If you slide this way, you have to think which one is on the bottom, which one is on the top. The bottom one, the green one, gonna be this function here. The top one gonna be here. Does it make sense? And then this is going to be the same thing with the second picture. This is going to be the top one, and the bottom one, so the right hand side one, sorry, the left hand side one gonna be this one. This is how you set up the integral into dimension, and your x value here and your y value here. On the outside integral, it's gonna be something on something that you trying to look at the interval here that you do the integration, or integral here that you do the integration. So we're gonna have more example for you to set up the integral, but once you do it, now you can like compute it. Let's suppose that I keep doing this one, and then I'm gonna integrate it now. So it's gonna be integrate 0 to 2. I integrate with respect to y, right? So I have y squared over 2, and then minus x times y. Because now I integrate with respect to y, so I treat x as a constant, and then y equal to 2x, and y equal to x squared here. And then you keep going, so it's gonna be integrate 0 to 2. We plug in 2x, 2x squared over 2, and then we plug into x. Here, this is the first term when you plug into x, and then the second term you plug in x squared. You plug in x squared and the x. You can see that what I did is just I integrate y minus x first, so I get y squared over 2 minus xy. This is I integrate with respect to y, and then after that I plug into x, and then I plug in x squared, so I plug into x to here, so I have that. I plug in x squared to here, so I have that. And then now you just need to integrate this one. This is a little bit tedious, but it is, like just the calculation, nothing new here. So 0 to 2, and then here you're gonna cancel a little bit, so you get 2x squared, right? And then now you get minus 2x squared, right? Which is a good one because this is actually 0 here when you do it. And then minus x to the 4th power over 2, and then minus x cubed. So basically this one gonna cancel out because 2x squared minus 2x squared gonna be 0. And then all you have left, you're gonna have integrate 0 to 2 x cubed minus x to the 4th power over 2 dx. And then now you can integrate it, so it's going to be x to the 4 over 4 minus x to the 5th power over 10. And then you plug in from 0 to 2. Which at the end you're going to get 16 over 4 minus 32 over 10. And that is the answer, which is 4 minus 3.2, which is 0.8. So what I expect you to do is I expect you to set up the integral here, which is more important than the integration here. The integration here you already learned in Cal 1. So the new thing that you learn here is just you need to set up the integral here. This is our focus for calculus 2. So we're gonna focus, can you set up the integral using the double integral? Order of integration gonna be dy dx or dx dy. It will be a little bit challenging at first, but once you pass 2 or 3 examples, you're gonna see the mechanism how you set it up, and it should be good. The question that students usually ask is, do I need to draw a picture? The answer is yes, you always need a picture, because if you don't draw a picture, you cannot do it. So which means in every question you need to draw a picture, otherwise you cannot get it. Okay, so we're gonna keep doing examples today, so I will let you finish copying example 37, and then we're gonna move to the next one. Okay, let me go to the next one. Example, well, this is a space for you to copy this one, but even if you do the same, if you do this term, you do the same thing at this question, you're gonna get the same number, 0.8. You can do either this one or this one, this doesn't matter. All right, so we're gonna move to example 38. So let's suppose I want to compute integral of x squared dA over the set D. You see that? I want to compute this thing over the set D, which means I give you the set D here. Picture is given, good for you. So D is the region bounded by parabola y equal to 2x squared and y equal to 1 plus x squared. So this is actually parabola y equal to 2x squared. This is actually y equal to 1 plus x squared. So the first thing that you need to do is you draw the picture. So once you draw the picture here, so now you're gonna set up the integral. So we're gonna integrate x squared. So which one you're gonna choose? So let's suppose that if you want to choose, let's suppose that I want to choose dy dx. So what would I do if I want to choose dy dx? It means that for the region D here, I need to draw the vertical line because it's, remember, dy first mean you taking a look at the vertical line. If you do dx first, it means you taking a look at the horizontal line. So this horizontal line. So this is just the difference. If you do dy first, you do the cut vertically. If you do the dx first, you do the cut horizontally. So here, if I want to choose dy first, I cut this like that, this way. So what I need is, I need to know which one is on the top, which one is on the bottom. So here, the yellow one gonna be on the bottom curve always, right? So the top curve gonna be the green one here, always. So the function that I need to put here is the green one. The function that I need to put here is the yellow one. So now you know that you start from y equal to 2x squared, the bottom one, to y equal to 1 plus x squared, the top one. So here should be 2x squared here at the bottom, 1 plus x squared here at the bottom. Make sense? Like every single x value that you are considering, so you're trying to do the cut here, bottom to top, bottom to top, bottom to top, bottom to top, bottom to top here. Make sense? And then you can see that every time when you do the cut, the bottom curve gonna be the yellow one, the top curve gonna be the green one. This is why you set up here to be 2x squared, you set up here to be 1 plus x squared. And then what is going to be your x value here? It means what are the range of the value that you do the vertical cut, which is going to be -1 to 1. Make sense? This is going to be like the x value that you do the cut -1 to 1. Does it make sense? Instead of doing the x dy, what if you want to do dy dx? Instead of doing the dy dx, what if you want to switch the order of integration? And if I ask you to do the x dy, this is going to be super terrible. Because if you do the x dy, you can see that you do the cut here, the cut here, the cut here, and the picture is gonna be super hard now because you have this y equal to 2x squared, the black one, and then you have the purple one, which is this y equal to 1 plus x squared. If you do the cut horizontally, it's gonna be something like you start from here to here, 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 and you can see that you're gonna have the first piece here, which you start from the black parabola and then you hit the black parabola. The second piece is here. The second piece is the one that you start from the black parabola and then you hit the purple parabola. And the last one is gonna be here. You start from the purple parabola and then you hit the black one. So which means when you do the x dy, you have to split the integral into 3 pieces. Like that. Boop, 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 boop. It's gonna be super terrible that you wanna do it. If you wanna do the x dy, and then you have to do, this is you're gonna be the first piece, the second piece, the third piece, and then you do the first one, the second one, the third one. This is terrible one. So we are not going to do the x dy because this is going to be the hard one, because you can see that if you choose to do it, you have to separate the region into 3 pieces. It's gonna be super terrible. So for this question, dy dx is easier. So we're gonna just keep doing dy dx. Does it make sense? They're gonna be on some question, dx dy and dy dx, they are, you know, like not hard on both the x dy and dy dx, but some question like this, the region is better if you do dy dx. Okay, so I guess we're gonna integrate this one now. So carry this one and then integrate it. Copy and then paste it here. And then now you want to integrate this one. So integrate. Okay, so first of all, you integrate x squared, so you get x squared times y, right? Because you integrate with respect to y. and then the x here, and then now you integrate by plugging in 1 plus x squared, and then minus x squared times 2x squared dx. So you plug in 1 plus x squared and 2x into the function, and then now you integrate. So it's gonna be integrate minus 1 to 1. This is x squared minus plus x to the fourth power minus 2 times x to the fourth power dx. Should be simple now. So integrate x squared minus x to the fourth power dx minus 1 to 1, and then now you're gonna get x cubed over 3 minus x to the fifth power over 5, and then you plug in x equal to negative 1 to 1. So you get the answer now. So 1/3 minus 1/5, and then minus negative 1/3 minus negative 1/5, which is plus. And then at the end, you're gonna see that some number cancel. Some number cancel. So 1/3 plus 1/3 is 2/3. No, it's just like can group it up, not cancel. Minus 1/5, and then minus 1/5 is minus 2/5. So this is actually 10 minus 6, which is 4 over 15. Okay, so this is how you integrate into dimensions. So first of all, I want to say one more time that the hardest part is you set up the integral here. Once you set it up, so you should be able to integrate it easily. Four over 15 is the answer for this question. All right, next one. Again, I will draw the picture here for just remind you that this is what we did. And then you just do the cut horizontally. That is why you set it up. This one. All right, the next property of the integral is that if you actually put the constant function fxy equal to 1 inside that, it's gonna be the area D. So what you have to think a little bit, it's a little bit complicated in terms of double integral, because the function that you have here inside here, this is a function that is on your top part, this is on the ceiling part. Basically, when you say that the region is D here, you actually put yourself on the domain D, and then the roof top gonna be this function x squared gonna be on your roof. So if you put the fxy equal to 1 inside here, you're gonna get the area of the function. So you're gonna get the area of the region. That is what you did. So example 39, I want you to compute the area of the region D, where D is the region bounded by the y-axis, the line y equal to x, the line y equal to 4, and the parabola x y equal to x squared, where x greater than or equal to 0. So let's trying to do this question together. So what would you do when you see this question? So you're gonna first draw a picture of the region D. So the last two examples I already gave you a picture, but this question you have to draw it by yourself. What is D here? So you're gonna draw the y-axis. You're gonna do the x-axis here. So when you draw the line, so you start from the y-axis, which is this one, the y-axis, and then you have the line y equal to 4, right? The line y equal to 4 gonna be this one, the line y equal to 4, and then you have parabola here parabola y equal to x square. Y equal to x square. Actually, you have y equal to x square here on both sides, but the question say you will want x greater than or equal to 0. So actually, the region that you want is actually this one. You agree? Okay. This is the region you want. This is the region D. So now, the theory say that if you want the area of D, you're gonna integrate 2 times. Put the one function fxy equal to 1 inside the integral and then dx dy. And then when you compute it, it's gonna give you the region D, the area D. So you can do either this one or this one, dx dy or dy dx. So what would you do if you pick the x dy? So if you pick the x dy, think this way. If you pick the x dy, it means you do x first. You have to cut with respect to x. So it's going to be, along the axis. So which means you're going to do the cut here, horizontal line. If you pick the y first, it's going to be you cut this way. So if you pick the x first, x going to start from where to where? So you have to think, oh, if you cut horizontally, the left hand side gonna be the yellow one here. The right hand side gonna be the parabola here. So it's every time you're gonna start from x equal to 0 to x equal to what? So I will just use a color here, and the pink one is this one. So for sure, if you do the x first, you have to start from the yellow one to the pink one, right? Yellow to pink, yellow to pink, yellow to pink, yellow to pink, yellow to pink. So it's gonna be the x start from where to where. So the yellow one is x equal to 0. The pink one is x equal to square root y, right?
Yes.
Because y equal to x square, so this means the same thing with x equal to square root y on the pink one, which means x is going to be square root y here. Does it make sense? And then y gonna be from where to where? Y here gonna be from, this is the range or the interval that you do the integration here. Y gonna be from 0 to 4. This is how you set up the x dy. Good. If you want to set up dy dx, so what would you do? It's both correct. You can do this one or this one, doesn't matter. Well, if you want to do dy dx, so now you do the cut here. So y gonna start from where to where? So you have to think, oh, which is the best to do y from where to where? So y gonna start from here, right? The bottom one to the top one here. So y gonna start from x squared to y equal to 4. Makes sense? Because x squared is on the bottom part, 4 is on the bottom part, top part. And then x gonna be from where to where? 0 to 2. Because this is actually the range of the integration. Basically, you need to find the intersection here when x equal to, or when y equal to 4, x equal to 2, right? So that is why you know that, oh, x gonna start from 0 to 2. This one or this one, they are both correct. You pick the one you like and then you do it. Make sense? And then now you can compute the region by plugging one here. And you just compute the region. So let's suppose that I hate this one because I don't want to integrate with square root sign. So I probably do this one. This looks easier to me. So 0 to 2. This is 4 minus x squared dx. And then, so I would have 4x minus x cubed over 3. And then I plug in 0 to 2. So I have 8 minus 8 over 3. This is actually 24 minus 8 is 16 over 3. You can see that the region D here has the area 16 over 3. Similar to this one, you can do it, but maybe it's a little bit harder or easier, I don't know. If you do this one, you're gonna have square root y minus 0 dy. This is integrate, so you're gonna get y to the 1/2, right? So you integrate, so you're gonna get y to the 3 over 2 over 3 over 2, and then you plug in 4 and 0, so you're gonna get 2/3 times 4 to the 3 over 2, which is 16 over 3 as well. So both way you're gonna get the same answer, but you can pick on the exam which one do you want to use. You can pick, well, based on your decision. If you think cutting on the vertical line is better, it's gonna be dy dx. If you think that cut on the horizontal line is better, it's gonna be the x dy. Depend on you. Or sometimes I ask both way. I just set up the x dy and dy dx in the same question, so you make sure you know how to set up both the x dy and dy dx. Good so far.
คุยไม่พอ
นะครับ
not far
I think we're gonna do one more example and then we have a break now, because like your head is getting messed up now. Well, this is the idea for the integration into dimensions. So I say that some region they are best treat when you do the x dy. Which one is better when you do the x dy? It's the one that you draw the horizontal line and you don't have to cut it. For example, like if you have, let's say, this curve and this curve together, so it means that when you draw the horizontal line here, you don't have to split the region as all. You can see that you just start from the function g1y to the g2y here, and every time when you do it, and let's suppose this is from 0 to 2, so you're gonna integrate g1y on the left, g2y on the right, and then you put the given function here, and then you do the x dy. This is going to be okay, because you don't have to separate the region at all, right? Because every time you from 0 to 2, you just start from g1 to g2. Instead, if you do dy dx, it's gonna be horrible, because you have to think that, oh, this piece, the bottom function is here, the top function is here. This piece, the bottom function is here, top function is here. You have to separate to like smaller region. It's gonna be terrible to do it. Like this question, like the parabola that we learned before here. This is the best treat if you do dy dx, because actually if you do here, you don't have to separate the region at all. But if you do the x dy, it's gonna be a little bit terrible, because you have to split into 3 pieces. It's gonna be harder for you to do it. So I say it is critical to learn how to switch the order of integration as well, because once you learn how to do dy dx and the x dy, so you need to be able to switch between them. So one example before we have a break here. Example 40, I give you dy dx here. I want you to switch the order of integration to the x dy. Okay, switch to fxy dx dy. How would you switch it? This is the required question on every calculus class. Like when you learn calculus, this is something like the mandatory question that you have to know how to do it. So if you start from dy dx, how you get back to the x dy? First of all, you can see that here you have the order of integration from 0 to 2x and 0 to 1. The incorrect one is that you swap it like that. This is wrong, completely wrong, because you cannot do it, because you can see that at the end you cannot have the variable on the outer part, because it's going to be impossible that you have the x here. It should be number. the domain is not rectangle, so you cannot do it. So what you're gonna do is here you think this way: y gonna be from 0 to 2x, right? For this one, x gonna be from 0 to 1. Can you draw the picture that represent this situation? So you draw y axis, you draw x axis. So what you want to do is, what is y equal to 2x? Y equal to 2x is this one. Sure. This is y equal to 2x, right? You're done with this one. And then y equal to 0 is what? Y equal to 0 is actually this line, y equal to 0. You're trying to put all information together to find what region are we integrating with respect to now. X start from 0 to 1. So it means x start from 0 to 1. This is 0, this is 1. So what do you think, what is our region? So you can guess first. Maybe I guess that our region is going to be the one that I highlight in green here. This is probably our region, right? Because it is the one that bounded by the curve that we just draw. So make sure one more time that you are correct. So if you integrate with respect to y first, so it means you draw the vertical cut. So it's gonna be this, and then it's gonna start from y from 0 to 2x, correct? So you start from y to 0 to 2x, right? And then x from 0 to 1, yes, correct. So now you swap back to the x dy with this picture. Can you get back to the x dy here? Okay. Should I random the name or just do it? dx dy. So x start from where to where? วรรัตน์ยิ้มบอกว่าอยากตอบครับ อยากตอบค่ะใช่ไหม No, dx dy, you can do it, right? For this one, it's easy one. dx dy, x start from where to where? So for those of you who cannot follow, you think, okay, the first choice from Supanat, from น้องก้า from น้องก้าตอบมาเร็วเท่าไหร่ถึงเท่าไหร่เร็ว x from where to where? 2 over y to 1. Anyone else? ใช่ชื่อก้าไหมมีเด็กไทยบอกว่าชื่อก้า
ใครบอกจ้ะชื่อผม
เอาเหรอ มีเด็กไทยบอกว่าแบบอาจารย์สอน CSPE หรือเปล่า มีคนชื่อสุพนัทชื่อเล่นชื่อก้าเราบอกอ๋อมันมีคนเดียวสุพนัท
อยากรู้ว่าใครเหมือนกันจริงๆผมเช็คได้นะครับ
2 over y to 1. This is, anyone have another choice? วรรัตน์เห็นด้วยไหมครับ You agree? ประพลเห็นด้วยไหมข้างหลัง เห็นด้วยมั้ย2 to y จริงดิ นะครับ Okay, x from where to where? Let's do one more time. So x, anyone one more choice? Okay. Okay, 0 to y over 2 as well. Okay, so let's see which one is correct. So x, the x here, you do the x first. So it's gonna be, you cut this way, right? You cut this way. So when you cut this way, the left hand side is here and the right hand side is here. So basically you start from this line to this line, but the left hand side you cannot put 2x here. It's impossible because this is x, so you have to simplify this one. And because you are so drunk, nah? So this is, should be x y over 2, no? This is not 2 over y, so y over 2. Okay, and then here y, x gonna end at 1. Make sense?
Make sense.
Okay. And then y gonna start from where to where? So you need to find the intersection here, because anyway you're gonna do cut here, the end gonna be here. So you need to find the intersection here when x equal to 1, y equal to 2. So basically you cut the horizontal line from 0 to 2. So it's gonna be like this. This is a required question on the exam. Everyone should know how to do this, because we're gonna ask you to switch dy dx to the x dy, or the x dy to dy dx for sure. So make sure that we're gonna learn after the break. We're gonna learn more example how to get the picture from this, and then from the picture you get the another order of integration. Make sense? Okay, so let's do until 11:10. Let's do 12-minute break and then we come back and do maybe 3 or 4 more examples. Okay ครับ so this is choice 1 นะ okay. choice 2 sorry
ใครถูกแล้วจะหา
choice 1 drunk people answer choice 1
ใครบอกว่าผมชื่อข้าใครอาจารย์ในภาคไหนอันนี้วิทยาหรือวิทวะเอาใครวิทยากับวิทวะอาจารย์
รู้สึกจะเป็นชวินนะกรุ๊ป C กรุ๊ป D นี่แหละ
อ๋อไอ้ป๊อป
ปอกใช่ไหมชื่อปอก
พ่อมันจัน
มันบอกว่าอาจารย์สอนคนชื่อก้าหรอใครมีคนชื่อก้าด้วยเหรอ CSP มันก็บอกว่าอ๋อสุพนัทถ้าสุพนัทรู้จักสุพนัท
เฮ้ยเกินไปมึงฟังกูนะเว้ยจบไปแล้วน้ำหนักกูจะลดเว้ยกูจะไม่เป็นทางโอ๊ตตอนนี้ไม่ไหวแล้ว
ไม่ได้อ้วนแต่เลย
จะเหลือเฮ้ยกับด้านน้ำหนักขึ้นเกือบ3 โลเพื่อนกูไม่เห็นความต่างเลยไม่ชิงกับกูก็ได้มั้งแต่กูต้องเอาแบบไว้ชนหลอกจานแล้วทวินตึงไหมจานทวินตึงไหม
มันเก่งใช่ไหม
มันบ้า
มันดูเป็นเด็กเรียนดีอยู่นะคะแนนมันได้เยอะอยู่
มันเก่งมันออกฟอร์มตั้งแต่ต้นแล้วจานแค่นั้นนะ
สนิทกันเหรอ
สนิทกันจาน
ทำไม dx ต้องตัดแกน y ทำไม dy ต้องตัดแกน z
อ๋อเพราะ
คือ
ว่า
ทำไมไม่ dx มันเป็นแบบ x เล็กๆเล็ก
ว่าทำไมมันถึงทำแบบนี้ใช่ไหม
ๆใช่
อืม
แบบอันเนี้ยมัน dx ใช่ไหมอาจารย์ dx มันก็ต้องเป็นแบบซอย x ย่อยๆแต่ทำไมแบบเราลากแนวนอน
เฮ้ยเราอัด